Hello, my name's Julian Raxworthy, and with my colleague Matteo Fraschini, we've got a presentation today that's called Territories Made by Measure, the Parametric as a Way of Teaching Urban Design. Our first premise for starting this paper was our teaching together at the University of Cape Town in South Africa, where we were running a subject that was called Urban Design Representation. And we were also at the same time teaching a history and theory seminar. And we made the decision to put these two topics together and to try to teach history and theory via Grasshopper. The aim of this was to try to demonstrate how urban design models are often parametrically based, and to actually allow the Grasshopper tool and the definition to open up the historic model and break down the traditional boundary between technology and history and theory. In our presentation today, we'll talk about a number of models, 3 models in particular that are historical, and those models are all European, and will reflect the fact that our backgrounds are also different. My background is landscape architecture, and so I take an approach that we're calling bottom up or outside in, while Matteo is an architect and urbanist, and so his is directed from the inside out into the street. Matteo?
Hi, yes, the idea was to try to give form to algorithms, and on the other side to try to find out numeric values on existing cities and on models. We focused on the importance of models in urban design, and as element that can be studied, have been important for the modernist and the modern cities. So we chosen 3 models. One was the, let's say, modernist city that we call ZEILENBAU, and we used the motto of multiplication. So the idea that the algorithm was started from the cell, the unit, and was a multiplication. The main purpose of this was to evaluate some of the basic modernist ideas on the city. That was the solar illumination and the density according to this, and the effect that this had to the city, the end of the perimeter block, and the distance between the city and the city and the cell. So the second one was CERDA'S, so the city of Barcelona. CERDA'S was the first that used the term urbanization, that is the theory, the science of the city. It was quite easy to start from him because it's a model for the, let's say, industrial city, and he himself used the specific algorithms, specific mathematical formula to define the grain, let's say, of the block, and the grain and the formal elements of the block. So in this exercise, we defined a few elements. One is the block, and one is the block, one is the grid, and one is the Avenida Diagonal, that is the element that links this Cartesian and, let's say, ideal array to the city and to a topography.
For our third example, using the name, the motto extrusion, we talked about what's known as Haussmannization. Haussmannization was the term that was given in the 19th century for Haussmann's, Baron von Haussmann's modifications of Paris. And for this algorithm, we focused on 2 major operations, really. The writing about this model has really talked about this idea of the green cut. And so that's the historical writing. from in the 1980s, where this was analysed extensively. For the term cut, it was really referring to the idea that the old Paris fabric was cut through by the boulevard, and we know that there are historical discussions around the role of the boulevard in terms of Napoleon II and the sort of civil order. And so that's really an extrusion and a subtraction operation. And then the second part of it is really the green part of the cut, which is really then an extrusion of the streetscape section along that. And the second part of the whole operation was then really about linking, or this sets up where the direction of the path is around linking the key points in Paris, which is a topographic thing. And so in conclusion, our aim with this paper has been to demonstrate how history and theory and parametric tools should not be separated, but in fact, parametric tools allow a way of opening up history and theory that is exciting and new. At the same time, we did notice some limitations, and those limitations specifically arose by the fact that by definition, a model is a perfect thing. In actual fact, the territory itself is actually very differentiated and topographically diverse. And so merging those two things is a more complex challenge, for example, than just simply teaching the model. And so this means that the next stage research would really be to try to bring those two things together, and which would in turn ground this more in landscape as well as urbanism. Thank you for this opportunity, and we look forward to responses from other authors and participants in the conference. Thank you.
Thank you very much. Thank you very much.